Okay, so today we are going to look at composition of functions. And what that means is you're basically going to take two different functions and put them together. But before we start doing that, let's kind of do a quick review of evaluating functions, which is something that will be helpful to remember how to do. So if you look up here, I have 4 examples we'll go through really quick. So if I have f of x, and remember f of x is just another way of saying y, and this is just function notation. If you have f of x equals 4x minus 1, if I want to find f of 2, that means I'm going to take anywhere I see an x in my function, I'm going to take it out and put a 2 in its place. So when I evaluate that, when I find f of 2, or when I evaluate f of 2, I would have 4 times, I'm going to take out x and put 2 in its place, minus 1. 8 minus 1 is 7. Okay? So, similarly, we can do the same thing over here, just a little bit more difficult function. We've got a quadratic here. We've got 3x squared minus 8. If I want to find f of 4, that means anywhere I see an x, I'm going to take it out and put a 4 in its place. So when I evaluate it, I would have 3 times 4 squared minus 8. Remember, order of operations tells us that we need to do exponents first. So I need to evaluate 4 squared, which is 16. So I'd have 3 times 16 minus 8. 48 minus 8 is 40. Okay, so not only can you evaluate functions for numbers like 2 and 4, you can also evaluate functions with an algebraic expression. So if I have f of x equals x plus 5, and I want to find f of z plus 1, that means anywhere I see an x in my original function, I'm going to take it out and put z plus 1 in its place. So if I'm going to evaluate this, I'm going to take out x and I'm going to put z plus 1 in its place, and then the rest of the function stays the same. So I would have z plus 6. Okay. Over here, again, we're getting a little bit more difficult with evaluating. I have x squared minus 2. I want to find f of y plus 2. What that's saying is anywhere I see an x, I'm going to take it out and put y plus 2 in its place. So what I'm going to do is I'm going to say y plus 2 squared, because I'm taking out x and putting y plus 2 in its place, minus 2. Remember, when we multiply y plus 2 times y plus 2, we need to FOIL, box method, however you want to do that, but we would get y squared plus 4y plus 4. That is this part. And then the rest of the equation stays the same, minus 2. That's that part. And now we just combine our like terms. So we would have y squared plus 4y plus 2. So we are going to take that idea and make it into composition of functions. So a composition of functions is created when the output of one function becomes the input of another function. The composition of the function f with function g, you see it written 2 different ways. Most commonly it looks something like this. You'd have f of g of x, or you would also see it sometimes as f. It looks kind of like the word fog, but it's a little circle that says of g of x. Those two mean the same thing. And if you had the function g, or excuse me, the composition of function g with function f, you would have g of f of x, or you could have g, little circle that says of f of x. And when you're evaluating these, you always do the inside function first. So let's take a look at what that actually looks like. Okay, so I have these 2 functions. I have f of x equals 3x squared plus 8, and I have g of x equals x minus 1. I want to know what f of g of 2 is. And on the previous slide, we said we start with the innermost function first. So I'm going to start with g of 2, and I'm going to evaluate that. So I'm going to say that g of 2, well, g of x is x minus 1, so g of 2 would just be 2 minus 1, because again, anywhere that I see an x up here, I'm going to take it out and put a 2 in its place. And so I would get g of 2 equals 2 minus 1, which is 1. So now I know what g of 2 is. Now I'm just going to evaluate f of g of 2, which is f of 1. Well, f of x is 3x squared plus 8. So now anywhere that I see an x, I'm going to take it out. I'm going to put a 1 in its place. And I get 1 squared is 1. Order of operations times 3 is 3. 3 plus 8 is 11. Okay, moving over here. This time we have g of f of 2. So we start with our innermost function first, which is f of x, and we're going to figure out what f of 2 is. Okay, so we have f of 2 is our first thing we figure out. Well, f of x is 3x squared plus 8. So I'm going to take out x, and I'm going to put 2 in its place. So I'm going to have 3 times 2 squared plus 8. Again, that's just using this function up here, and I'm taking out x and putting 2 in its place. So I would have, order of operations says I need to exponent first. 2 squared is 4. 4 times 3 is 12. 12 plus 8 is 20. So now I know what f of 2 is, so now I'm going to compose that with my function g, and I'm going to say g of f of 2, so I'm going to say g of 20. Well, g of x is x minus 1, so I'm going to have 20 minus 1, which is 19. So we always start with our innermost function first and work our way out with our substitution. If you look down below here, it's a little bit tougher because we've got algebraic expressions, and we're just going to compose those those functions. So I have, what I want to find is f of g of x. Okay, well, my innermost function is g of x. Okay, so what I'm finding, so I know that g of x is 4x. I'm finding f of that, which means I need to find f of, well, g of x is 4x, so I'm finding f of 4x, which means using my f of x function, anywhere that I see an x, I'm going to take it out and put 4x in its place, which means I would have 2 times 4x plus 4 over 5 times 4x. Again, all I did was I put 4x in my function f anywhere I saw an x. And then when I evaluate that, 4 times 2 is 8, I would get 8x plus 4 over 20x. And these are not going to end up being a number because you're not evaluating for a specific value, you're evaluating for a specific function. Okay, and then on this one over here, I have g of f of x. Okay, well, looking at my innermost function here, f of x is 2x plus 4 over 5. So I need to find what is g of 2x plus 4 over 5x. Okay, well, my g of x is 4x. So again, anywhere that I see an x in that function, I'm going to take it out and put 2x plus 4 over 5x in its place. So I'm going to say 4 times 2x plus 4, because remember, I'm taking out that x and putting the function f of x in its place. And I would get, can't forget to distribute here, I would get 8x plus 16 over 5x. Okay, so let's just try that again. Let's look at another couple of examples here. So we have f of x is 3x squared plus 8, and g of x is x minus 1. And I am finding f of g of x, which means I'm going to use my function f, and I'm going to evaluate it for g of x, which means I'm going to have my function f that I'm going to use. I'm going to evaluate it for g of x. I'm going to say f of x minus is x minus 1. Okay, so my function f of x is 3x squared plus 2, so anywhere, or 3x squared plus 8, so anywhere there's an x in there, I'm going to take it out, and I am going to put x minus 1 in its place. So I would have 3 times x minus 1 squared plus 8. And then it's just some evaluating. Remember, x minus 1 squared is x minus 1 times x minus 1. Okay, so we'd have 3 times, when we multiply those out, we get x squared minus 2x plus 1. And then that plus 8 is still hanging on there. Get that out of the way a little bit. Now we need to distribute that 3 in there, so we have 3x squared minus 6x plus 3, and then we bring down that 8. So our final answer would be 3x squared minus 6x plus 11. So when we evaluate our function f of x for g of x, we get 3x squared minus 6x plus 11. Okay, again, same idea here. We have g of f of x. Okay, so let's look here. So we are going to evaluate g of, well, f of x is 3x squared plus 8. So we're going to have 3x squared plus 8. Okay, well, g of x is x minus 1. So anywhere that there's an x, we're going to take it out and put 3x squared plus 8 in its place. So I'd have 3x squared plus 8, and then minus 1, because that's the minus 1 that's here. And we would get 3x squared plus 7. So there's some examples for you. You have a class kick, a couple questions in class kick that you need to work through for homework today. And please let us know if you have any questions.